Let's go ahead and take a look at an example where we're using the limit definition to find the derivative of a function. So we're going to be using option 2 on this one, where we're going to take a look at the limit as h goes to 0, f of a plus h minus f of a over h. So let's go ahead and get a function to work with. And let's take a look at the function 1 over x. So we want to calculate f prime of x. And we're going to be using this limit definition. We'll adjust the variables to account for the fact that we have x's in here instead of a's. So we've got limit as h goes to 0, f of x plus h minus f of x all over h. So let's go ahead and substitute in the pieces that we have. Make sure you keep your limit notation. Right? H is going towards 0. And we need to calculate f of x plus h. So keep in mind, you're going back to your original function here, and if you're calculating f of x plus h, right, we're going to be putting in x plus h every time we see an x in our function. Right, so this is going to give us 1 over x plus h. Right, if we substitute that in for x. And we're subtracting f of x. Well, f of x is the original function that we started with. That was 1 over x. And all of this is going to be over h. Now, you have fractions inside of fractions. Most people probably don't want to work with that scenario, so I'm going to go ahead and pull out the 1 over h so that it's out in front. And that's going to clean up this function just a little bit. So I've still got my limit as h goes to 0. You can kind of think of a 1 on top of here. So I'm going to pull out the 1 over h. And that's going to leave us with this 1 over x plus h minus the 1 over x. Okay, and I'm going to go ahead and put this inside of brackets just for clarity. Now let's work with the stuff inside the brackets, right? We need a common denominator so that we can subtract these two functions. And so the common denominator here is going to be x plus h times x. So I'll keep my 1 over h. Okay, and I'll write this out the long way so you can see it. Right, here's my original function that I had, the x plus h. Right, I'm going to have to take this entire denominator, and we're going to have to multiply this by x. Right, that's the other denominator that we were looking at. And I can't just multiply the denominator by x, right? If I do something to the bottom here, I have to do the same thing to the top. So we're going to multiply this numerator by x as well. Right, this is the equivalent of multiplying by 1. Right, we're not changing that fraction at all. Right, we're just going to be rewriting it. Okay, my subtraction sign. This was my original 1 over x. Right, I need the common denominator for that second fraction. So we're going to have to multiply this one by x plus h. Again, I can't just do it to the denominator, I have to do it to the top as well. Alright, now let's go ahead and simplify the loop. This will be the limit as h goes to 0. My common denominator here, I'm going to go ahead and write this all over my x times x plus h. Okay, and let's go ahead and simplify our numerator. 1 times x is just going to give us x. And then I'm going to go ahead and take this as a -1, right? This is my subtraction sign here. I've got my 1. I'll take that all together as one thing. I've got -1 times x, which will give us a -x, and -1 times h, which will give us a -h. Again, let's simplify. Don't lose your limit notation. 1 over h. If I combine the like terms up here on top, x minus x is going to be 0. So we've got a -h over x times x plus h. Alright, so let's go ahead and cancel the pieces that we can. Notice you have an h in your numerator, and you also have 1 out here in the denominator. They're being multiplied, right? So I can actually divide these out. That'll divide out to give us a 1, right? You still have the -1 on top, so don't lose it. -1 over x times x plus h, right? And our h value here is going towards 0. Right? So whenever you go to make that substitution and put 0 in for h, you can stop writing your limit notation. Alright, so I'm going to go ahead and substitute the 0 in at this point. Alright, so I've got -1 over x times x plus 0. And this is going to simplify to give us -1 over x squared. Alright, so our derivative here, f prime of x, is going to be equal to -1 over x squared.